Hey guys, Miss Seifert here. I guess my camera's decided to stop working, but we're going to do a review of water. I'm going to move through this super duper fast, and hopefully I'm going to get through all of it. But water's really important all over Earth for a variety of reasons, and I want to make sure you guys get all the information you can. So, of course, we're talking about the water cycle, and you guys have done the water cycle forever and ever and ever. I know you were probably in pre-K or kindergarten when you were talking about evaporation, but we added a few things along the way. So we have not only evaporation, condensation, and precipitation where it falls, but we also have evapotranspiration, which is the water vapor released by plants back into the atmosphere, and this is really important, okay? You also then have runoff on the surface, you have groundwater, just a lot of things that we're going to get through. Okay, so weather measurements, probably could have thrown this in the weather video, but here it is under water. You've got barometer, which measures air pressure, thermometer measures temperature, psychrometer, humidity, rain gauge, the amount of rain, anemometer is the wind speed, and the wind vane tells you the wind direction. So different types of clouds that are formed can tell us a lot about what the weather is going to do. So our stratus clouds are pretty flat. They're pretty low-lying, flat clouds. Cumulus are puffy. They look like cotton balls. Cirrus are very, very high in the sky, and they tend to actually be made of ice. Altostratus or cumulus tend to fall in the middle of the troposphere. Nimbostratus will tell us that there's going to be rain, and cumulonimbus, we're looking at thunderstorms, those really big thunderheads that come in. So thunderstorms, tornadoes, and hurricanes, all of them are associated with very low pressure. With extremely low pressure, you're going to get bigger storms because low pressure allows for that cloud development. And so this is super duper important. So with thunderstorms, we've got a low pressure system. Tornadoes happen in extremely low pressure, and hurricanes, which form over water. They form over warm water. That hot air coming off Africa that gets over the warm water in the Atlantic actually forms those hurricanes, and eventually they make our way to us. And because of that low pressure, you get that storm surge. Remember that the surface of the ocean actually comes up a couple feet in the eye of the hurricane as it's coming towards us. So regardless of how the rain comes down, we get precipitation, and a lot of it ends up going into ground. It actually gets absorbed by the ground, and that's really important stuff called groundwater because we need it for a variety of things. You have a saturated zone as well as an unsaturated zone. So your saturated zone is going to be where when you dig through the dirt, there's water there. Your unsaturated zone does not have water there. And the water is kept in the saturated zone by that impermeable rock layer underneath, or bedrock. Okay? If you are pulling water from the groundwater, you end up with what's called a zone of depression. And so this can actually lead, if you overuse groundwater like on a farm, this can actually lead to depressions in the ground on the surface, and that's probably a problem too. You can see some other things that can affect our groundwater, any leaking sewers, urban runoff, landfills, gas stations, any sort of industrial storage or contaminated land. When you have stuff that soaks into the ground, eventually it starts affecting that groundwater, which means it can affect the wells that people use in order to survive. So karst topography is very, very specific. This is where we have the remains of ancient coral reefs, limestone, which have become weathered over time, that water has actually carved caverns into them and has dissolved some of that limestone. Now, if it dissolves enough of the limestone, it will actually collapse into the cavern or into the cave, and this is called a sinkhole. So you can end up with sinkholes in areas of karst topography. And what happens is the water actually dissolves it into carbonic acid. Stalactites hang tight to the ceiling. Stalagmites are like little mountains on the floor. And you can also get columns, which are areas of rock that for whatever reason have not completely dissolved. And so you'll find caverns in regions of Virginia like Valley and Ridge, the Ray Caverns, and those are the remains of ancient coral reefs. So they have a lot of limestone as part of their bedrock. Streams on the surface. So water that doesn't necessarily go into the ground, but that runs off the surface. A youthful stream, you get those V-shaped valleys. It's very fast. It has a lot of rapids, a lot of waterfalls. It is curving downward with steep slopes on either side. Okay? In a mature river, it moves a little bit. what we call meanders, it wanders a little bit. It also has carved some floodplain. It doesn't move quite as fast, but you have some areas that are flat because the river has flooded before, and when it floods, it tends to carve out those plains, like the ones that we've got in downtown Lynchburg, right along the riverfront. You've got that nice flat area, but when we get big floods, that area is going to flood. Very old rivers, like the ones we see in Africa, you've got a very wide floodplain with lots of meanders. The rivers actually wander, and you actually end up with oxbow lakes. You may also see deltas at the mouths of these rivers where they've just carried sediment for so many years and deposited it for so many years that you have a delta at the mouth of the river. Very rich land there, can kind of be swampy though, and it's just all the sediment that has been deposited for so many years. Okay, so weathering of rock, we talked about rock in a different video. Physical, the pieces of the rock remain the same as they were before. Chemical, the rock actually changes form. So whether that is limestone getting dissolved, whether that is iron that rusts, you end up with a different rock than what you previously had. So erosion is the carrying away of sediments. So gravity is a big one. Slump, creep, rock slide, and mud flow on the video I did the other day when I was out sick. Also water moves a lot of sediment. Wind can move a lot of sediment, and glaciers create these big U-shaped valleys as they carve through. Okay, so if we follow the flow of water, once the water gets to the ocean or lake, it's still depositing those sediments. And we talked about how, like, when you get to the bottom of a water slide at the water park and you get into that pool of water, you slow down, just the same way that creeks, rivers, and streams heading into a larger body of water, they lose momentum, they slow down, and so your big particles drop out first and your small particles drop out last. So you're going to find large particles of rock towards the mouth of the river, but a little bit further out, you're going to continue to find some smaller particles like sand and clay. Okay, so deposition that's happening, also the ocean, the waves themselves are not only weathering rock along the shoreline, but they are actually moving the sand back and forth. And a lot of that sand actually came from other regions, and it came down through creeks and streams and rivers that made their way down to the ocean. So the shoreline is where the land and the body of water meet, and not all of them are necessarily beaches. When I went to Massachusetts in the fall, most of the shoreline was very, very rocky. But there are parts about beaches, and beaches is material that is deposited by waves. So again, you could end up with a lot of sand, you could end up with a lot of rocks. It just depends on where you are. Sea arch forms when waves erode through a sea cave. So waves are carving away at the rock along the side, and where you've got soft pieces of rock, it forms a cave, and if it goes all the way through, you get a sea arch. Okay, there's the sea cave. Probably should have put these in the opposite order, but waves cut into the cliffs at weak points or in soft rock. Okay, and headlands are finger-like cliffs that form when surrounding rock erodes away. Okay, let's talk about the waves themselves. You've got the crest, you've got the trough, and the difference between the crest and the trough is the wave height. The distance between two crests is the wave length. Okay. Ocean currents cause waves and currents on the surface of the ocean and on lakes. Now, these are different from tsunami, and tsunami are really spectacular. They are incredibly destructive, and these are formed from an underwater earthquake, typically at a subduction zone, where you have a fault that shifts so much that it causes a massive column of water, and that can do a lot of damage to people who are on the affected shorelines. Okay, currents moderate weather along the coast. So you've got warm currents that move away from the equator and your cold currents moving toward the equator. Same thing happens in the southern hemisphere, warm currents moving away, cold currents moving toward. And why do these go different directions? Well, because the Earth is spinning, and because the Earth is spinning, we end up with these curvature of ocean currents. The most famous one is the Gulf Stream, which actually warms quite a bit of Northern Europe. If you look at Northern Europe, it's way far north than, say, Maine or regions of Canada. However, people are still able to live up here, mostly because you have that warm water that's coming up from the Gulf. Okay, tides. Tides are formed by moon's gravity. So when the moon is lined up, either the Earth, Moon, and Sun are lined up. So we're either having a new moon or we're having a full moon. We end up with what are called spring tides. And you'll see this where the water kind of swells out a bit. And what's happening is you get a really high tide and a really low tide. This only happens when you have Sun, Moon, and Earth, or you have the Sun over here, the Earth, and the Moon over there. So if they're in a straight line, you're going to get a spring tide. Okay, a neap tide happens where you get not much of a high tide and not much of a low tide. This happens when the moon is in third quarter or first quarter, because the sun being over here, the earth and the moon are at 90-degree angle. 90 degrees gives you a neap tide. Okay, so the seafloor is also really important. You have continental shelf, the continental slope where it starts to slide down. An abyssal plain is a really deep flat area of just ocean floor. The mid-ocean ridge is where we have that seafloor spreading, and any trenches. This is where you've got different plates that are colliding into each other at a convergent plate boundary. Okay, so cross-section of the ocean floor may look something like this. A seamount is not quite to the surface, where an island actually gets out over the surface. So your continent, your shelf, your slope, okay, and then you may have a trench, very deep, abyssal plains, a rift. This is where you can see the arrows are pointing to the movement of those different plates. Okay, and so those things may in fact be on your SOL. That's all I've got for water and oceans. Y'all have a good one.